Just wanted to do some examples for you. I'm going to do two from the page 2 and 3. Page 1 is just a list of directions. If you want to see written out steps on how to do this, you can read that page. But the second page and the third page have easier structures on it, and then the fourth page are the challenge structures. So I'm going to do one from the easy ones, and then I'll do a couple from the hard ones. So I'm going to start with this naming one over here. So this is number 8 on that first, on the second page. And I'm going to name this structure. So I'm going to find, first step, I'm going to find my longest carbon chain. So here I have 1, 2, 3, 4, 5. If I just go straight across. If I go, let me see, up and down, 1, 2, 3, 4, 5. Okay, let's see if I turn a corner. 1, 2, 3, 4, 5. So it's 5 no matter which way I go. So I can pick any way I want. So I'm going to go from top to bottom. 1, 2, 3, 4, 5. So that's pent. If you remember our prefixes from the notes, 5 is pent. And then because they're all singly bonded, I'm going to end it in A-N-E. Remember, the single bonding ending is A-N-E. So that's my longest carbon chain, this one here. I do suggest you circle your longest carbon chain. It makes it easier to see when you have branches. So I have 2 branches here. When I have 2 branches, the prefix is di. And then I have to figure out what those branches are. If they were 2 different kinds of branches, let's say one had 1 carbon and one had 2, I would say methyl and ethyl because I had a 1 carbon and a 2, so I'd have methyl ethyl. But here, because they're both 2 carbons, that's eth. And then remember, we end our branches in YL, so diethyl pentane. And I have to say which carbon they're attached to, and because I numbered it, I can see right there, they're attached to number 3. So I actually kind of ran out of space here. So I'm going to say 3,3 diethyl pentane. The reason you have to say 3 twice is because they're both on the 3. If I had 1 on the 2 and 1 on the 3, I would say 2,3. If I had 1 on the 2 and 1 on the 4, I'd say 2,4. So that's why I have to say 3,3 is to show that they're both on the 3rd carbon. All right, going to the drawing one. So here, if you have the name and you're going to a drawing, I suggest that you break the name into parts. So here is my longest carbon chain, pent. That's 5 carbons. Ane, so I've done that. Ane means that they have single bonds. I gave them all single bonds, great. Then I have di, which means that I have 2 of something, and I have 2 methyl groups. Methyl's a 1 carbon chain. So this means I have 2 1 carbon chains, and then where are they? On the 2nd and 3rd. So I'm going to count in 1, 2, and I'm going to put a 1 carbon chain there. That's my first methyl group. I have another methyl group on my 3rd carbon, so I'm going to put it there. I could have put it on the top. It doesn't matter, I could have put it up there as well, but I know I have to draw hydrogens in, so I'm just going to put it as far away as possible so I have the most room as possible to draw hydrogens, which is what I'm going to do now. Now I'm going to add hydrogens. So remember our rule that every carbon needs to make 4 bonds. So this first carbon here is making 1 bond, which means I need 3 hydrogens. This second carbon is making 3 bonds, so I only need 1 hydrogen. This carbon up top is making 1 bond, so I need 3 hydrogens. This carbon right here is making 3 bonds, so I only need 1 hydrogen. This one on the bottom down here is making 1 bond, so I need 3 more hydrogens. This carbon here is making 2 bonds already, so I only need 2 hydrogens here. And then this last carbon is making 1 bond, so I need 3 hydrogens. So there is my structure. I put up number 8 just because I wanted to show you guys for N. If you could just do 2-butine. Actually, why don't I just do it for you since it has the Y-N-E ending, we can see what that means. So I'm going to, instead of N, I'm going to do 2. So bute is 4 carbons, 2, 3, 4, and then Y-N-E means I have a triple bond somewhere. Where is my triple bond? On the 2nd carbon. So I'm going to count in 1, 2, and that's where I'm going to put my triple bond. So now I have to add hydrogens. Hydrogens are... remember, every carbon needs to make 4 bonds. So this carbon is making 1 bond, so I need 3 hydrogens to make 4 bonds total. This second carbon is already making 4 bonds. 1, 2, 3 in our triple bond, and then this 4th one over here. My next carbon is also making 4 bonds. It's still the triple bond, and then this additional 1 bond here. And then my last carbon is only making 1 bond, so I need 3 hydrogens there. So there is my structure. Moving on to ones that are a little harder. I wanted to show you one of these. That's a shorthand one. So remember, the shorthand ones have carbons at every point and every change. So I change directions, I have a carbon, I end, I have a carbon. So how many is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is known. And then because they're all singly bonded, I call it ane, so nonane. And then there's no branches, right? If I erase all those carbons, you can see clearly there's nothing coming off of it. So it's just nonane. That's it. Here, I'm going to break this up. Pent is 5 carbons. And then I have diene over here. So that's 2 double bonds. Diene. Di means 2, and then ene means a double bond. Remember, ene is a double bond, yne is the triple bond that we saw before. So where are those double bonds? One is on the second carbon and one is on the 4th carbon. So I'm going to count in 1 carbon, 2. So there's my double bond, and then 3, 4. There's my other double bond. So now I'm going to add hydrogens so that every carbon is making 4 bonds. It doesn't matter if you put them like above or below, as long as each carbon is making 4 bonds, that's what we care about. So there we go. 2,4-pentadiene is that molecule. Here's the benzene ring. If you guys remember that from the notes, that circle in the middle is shorthand for double bonds. So that's benzene. And then, whoops, benzene. Spelled it wrong, sorry. Benzene. And then I have a methyl group coming off of it. 1 carbon is meth, and then we end our branches in YL. So methylbenzene. Here, this is kind of a long one too, but I think you guys can do that one, or maybe I'll show you that one and then you guys can try 9. So I'm going to do 7. I'm going to do it over here. So I'm going to start by doing the oct first. So that's my longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons. Diene means I have 2 double bonds, or 2 triple bonds, sorry. One's on the 4 and one's on the 6. So 1, 2, 3, 4, I have a triple bond there. 5, 6, I have a triple bond there. And now I have 2 chlorines. They're both on the 2nd carbon. So chlorine, chlorine. So now I'm going to add my hydrogens. Chlorine doesn't get any hydrogens, just the carbon does. And again, you only want to put it on the carbons that don't have 4 bonds. So there we go. Next one is this benzene one again. So I'm just going to write the word benzene. That takes care of the circle. Now I'm just going to do the substituents. So I have a bromine one, so I'm going to say bromo, because remember we dropped that I-N-E ending and we add the O. And then I have fluoro, but I have 2 of them. So how do we say 2? Difluoro. And then I have to tell you which carbons they're on, so I just want to give them the smallest numbers possible. So if I number them this direction, like 1, 2, and then this is the 3rd carbon, and then 4, so 1, 2, 4. And then I want to put them in order that I listed them in the name. So 4, and then 1, and then 2. So my name is going to be 4, 1, 2, bromo, difluorobenzene. I know that one's hard. You guys won't see one like that hard on your tests or anything, but just good practice. All right, so as you work through this, please let me know if you have any questions.